Entities in ER diagram. Entities represent real-world objects like customers, products, or orders. Each entity has attributes that describe the property of the entity. For example, in a university database, students and course could be entities. Attributes in ER diagram. Attributes are characteristics or properties of entities. They describe the features of an entity. Attributes can be simple, example age, name, or composite, example address. Types of attributes. Key attributes uniquely identified an entity within a set. Composite attributes are made up of smaller sub-attributes. Derived attributes are calculated from other attributes. Example of attributes. In a car, entity attributes could include license, plate number, and model. A customer entity might have attributes like name and email address. Attributes help define the structure of the database scheme. Relationships in ER diagram. Relationships describe how entities are related to each other. They show how data is connected in the database. Relationships can be one-to-one, one-to-many, or many-to-many. Types of relationship: one-to-one, one-to-many, many-to-many. Example of relationship: in a bookstore database, a customer can have multiple orders one-to-many. A student can enroll in multiple courses, and course can have multiple students. Relationships help establish connection between entities. Cardinality in relationship. Cardinality describes the number of instances an entity can be associated with another entity. It can be one, zero, or more, one or more, or exactly n. Cardinality constraints self defines the nature of relationship. Examples of cardinality. In a library database, a book can be borrowed one or more members, one to many. Cardinality constraint ensures that the relationship is properly defined. Your third bullet. Weak entities in ER diagram. Weak entities depend on another entity for their existence. They do not have primary key attributes. Weak entities are identified by their partial key and identifying relationship. Example of weak entities. In a dependent entity, the existence depends on the employee entity. The partial key for dependent could be name and relationship to employee. Your third bullet. Aggregation in ER diagram. Aggregation represents a part, whole relationship between entities. It is used to show that an entity is made up of another entity. Aggregation helps in organizing complex system in ER diagram. Example of aggregation. In a university database, the department entity could be aggregated into the faculty entity. This shows that a faculty consists of multiple departments. Your third bullet. Conclusion. ER diagrams are essential for designing database schemes. Understanding entities, attributes, and relationship is crucial for creating effective ER diagram. By using example and different types of relationship, complex data structure can be represented accurately. This concludes the 15th represent on the ER diagram for the types of attributes in a relationship. Thank you for your attention.